Here we are in 2007, question 1, part B. Now, this is a linear velocity question, linear acceleration question, and it's a multi-stage question. So the train accelerates uniformly from rest, continues at this speed, then decelerates. All right. So first part of this is going to draw a speed time graph. Well, that's just like most of our normal ones here. Speed and time. All right. It starts from rest, accelerates uniformly, straight line, continues at this speed for a while, and decelerates. Okay, we're not really given any information on how fast it's accelerating or decelerating, or even the speed, but we're told that we're going to call it v. That's v there. That's a little bit of a 0. So with any of these questions, we're going to divide them into our 3 little parts, 1, 2, and 3. Now, we are told a bit more information at this one here. We're told that the total distance is d. Okay, so total distance equals d. Let's pop that down there so we know it. And we're given a bit of information on each of these ones. So in the first part of it, this distance is pg. All right, not told anything about this guy. And the other distance is qd. qd, where p and q are less than 1. So these are just fractions of d. All right, and the total distance here, well, this one is going to be d minus pd minus qd, because they all have to add up to 1. Okay, now that's our speed, distance, time graph pretty much done. We're going to put a few little things here, t1, t2, and t3, because we'll need those later on. All right, part 1 sorted. Now, part 2, if the average speed of the train is v over p plus q plus b, find the value of b. All right, let's have a think about this. The average speed is the total distance over the total time. All right, and that in our case is d over t1 plus t2 plus t3. Okay, total distance we're told is d, and there's our 3 little times. Now, if we have a look and compare that to what's in the question here, I don't see any t's. So this is our first little problem. We want to get rid of these guys. And again, if we're stuck for what to do, well, they've given us the total distances, so we can begin to use these ones. All right. So if we think of this one, again, using our idea, the distance equals area under graph. For part 1, the area of this guy is half t1 by v, and that equals pd. So we just do a little bit of rearranging that one. We'll say that t1 equals 2pd over v. All right, I'm going to swap this out in a little minute there. Same idea again and again and again. So in this case, vt2 equals d minus pd minus qd. So therefore, t2 equals d minus pd minus qd all over v. And again, a half vt3 equals qd. So t3 equals 2qd all over v. Okay, so now this is getting a little less horrific. We'll just adjust that slightly there for you. Okay, now that's the third one, pretty much exactly the same as part 1. So now we're going to sub these in here. So I'm just going to come up there so I have a bit of space. Sub in t's. So the average speed is d all over, that's going to be nice and big now, t1, 2pd over v, plus d minus pd minus qd all over v, plus 2qd all over v. Okay, looks a bit ugly, but at a glance, if we look at this, we have a lot of common factors with D in it. We have a common denominator down here with V in it. So this actually isn't nearly as horrible as it looks at first glance. Just move our sign over here a bit to make a bit more space. So first thing, I'm going to multiply everything by V. Alright, so we're going to get VD all over 2PD plus D minus PD minus QD plus 2QD. Okay, because I just don't like fractions and fractions, so we'll get that one out of the way first. Now, secondly, we'll do a bit of housekeeping. Let's tidy this guy up here. 2PD minus PD is PD. We have a D here, and nothing else. That's grand, plus D. So, okay, just to keep track of things, we've dealt with this guy, we've dealt with this guy, and now we just have that one there. Because you don't want to leave one of these little lads out. Minus QD, so that is plus QD. This is looking good. If we go back and check where we're supposed to be going, I see P's, I see Q's, I see V on the top. That's going to come out nicely. Next step is to divide by D. So we know what V over P plus Q plus 1. Just a little bit of rearrangement there. P plus Q plus 1. And if we compare that to our original question, that equals V over P plus Q plus B from question. Therefore, scoot up a small bit, B equals 1. Nice and tidy.